This is the conductivity sensor. It's used in quite a few of our lab manuals. It shows up in the chemistry manual, the biology manual, water quality for, say, total dissolved solids. So it's a real useful sensor across the board there. We want to cover a little bit of how you use this sensor. What it does is it's measuring the conductivity in the solution. So it's actually using electricity to be able to do that. And the important thing to be able to do is to place your probe down into the liquid deep enough that you're actually covering the lower part here where the sensor is. And so you need to be able to put that in there. This is a multi-range sensor. It has a switch here on the end. And this allows you to adjust it for what you expect your values to be. And so it's a sensitivity switch. And so it's important to have that where you think your ranges are going to be. So if you're doing a particular lab from one of our manuals, they usually will tell you to have it in one of the other ranges. Now, if you're doing something on your own and you're not quite sure, you could just test your solution in maybe different ranges to see if it works out there. And so it's got a 0 to 200, 0 to 2,000, and 0 to 20,000 microsiemens is the unit there. So let's collect some data. So to do this, I need to immerse this in my distilled water, and I have this attached to the Vernier stir station. And I'm just going to have it drop some salt water into there and change the conductivity of this. So the first thing I need to do is put this on the electrode support bracket here. And I'm going to put it here, and I need to attach this magnetic stirrer to it. And so in order to do this, I'm just going to slide it up the side there, bring it around, lower it down into my solution. There we go. Let that slide down in there. So I have the tip submerged at this point, and maybe I'll turn this up a little bit so that it's starting to stir. So now I'm ready to attach my sensor to the LabQuest. It is an analog sensor, so I'm going to plug it in here. And when I do this, it's going to default to finding the sensor there. And so it knows that I have plugged this in, and so it's giving me the meter screen there and the current reading on the sensor. And it's actually fairly close to 0 here. This was distilled water. My beaker may have been a little bit dirty, and so it may be reading slightly above 0 there. I'm going to adjust my range before I actually get started here. Right now I have it on 0 to 200. And I suspect that given what I've done here is that as I start to add the salt water that the conductivity may increase fairly rapidly. So I may do like 0 to 2,000. And we see our meter screen here, and it's giving me a reading there close to 0 for my distilled water, so that's nice. The collection parameters up here in the upper right corner are time-based, meaning that we're looking at conductivity as a function of time. The rate is 1 sample per second is the default for 3 minutes or 180 seconds. And so that's perfect for what we want to do. We're going to start adding salt water and see what happens to the conductivity. So I'm ready to begin collection. So I'm going to press the start button down here and let it start collection. And then I will open the valve and let the salt water start to drip into the beaker. And as we do this, we see that the conductivity of the solution begins to rise. And we've collected data probably long enough now. We could let it run out to the 180 seconds, but I think we have enough data to be able to do our analysis. Maybe we're interested in the rate of increase of the conductivity as we drop the water into there. After we hit stop, the graph auto scales, and it's making it as large as possible given the data we've collected. So it looks like a nice increase in conductivity. It's fairly straight there. There's a little bit of bumpiness, and that's caused by the stirring action. If we don't stir it fast enough or it's not quite mixed, you may get a little bit of bumpiness there on the graph. But it looks like a fairly steady increase after I started adding the salt water at that point. So we would like to do the analysis, and maybe we want to fit that this part of the graph here with some kind of mathematical equation. So it looks like it's a line to me. So what I want to do is highlight the region of the graph, maybe go all the way over there. So that's a nice section of the linear portion of the graph. And to do the curve fit, I want to go to Analyze, and I will do Curve Fit and check the box next to Conductivity. And in the upper right corner there it says Choose Fit, so it wants me to find an equation there. So I'm going to go up and we'll try linear. Looks like it fits fairly nicely there, and I hit OK. And so now it is fit that section with a line, and so I end up with the slope-intercept form of the equation there, and my slope is 13.53. So that would be the increase in conductivity as a function of time for this graph. So again, this is the Vernier Conductivity Probe. It's used widely across a lot of our different labs, labs from all of the chemistry manuals, all of the biology manuals, environmental science, water quality. So labs such as watershed testing, conductometric titrations, total dissolved solids, and maybe diffusion through membranes. So it's definitely a very versatile probe.